Hello student, today we are going to discuss some new points from the lesson current electricity. What we have discussed in the last session? In the last session we have discussed when resistors are connected in series, that means one after another, then resistance increases and because of that current decreases. That part we have discussed. Today we are going to discuss more detail about these resistors in series. See, I am having two bulbs. This is the bulb number first, this is the bulb number second. So bulb here we are having filament, and the filament is made up of a metal which is having the little more resistance or a semiconductors. It is of tungsten. Then R1 is a resistance of the first bulb, and that is 2 ohm. And R2 is a resistance of second bulb, that is 3 ohm. That means together we see here one end in between this A to B. This is the first resistor, and the end of first resistor has connected to the end of the second. And so this kind of connection is called as resistors in series. Some more things we should discuss here. If one of these bulbs do not function, or if it is not in work or not functioning, then definitely circuit get crack, and because of that circuit having not continuity, electricity will not flow. So if you are connecting both the bulbs in series, that means you have to take work from this bulb at the same time. If any bulb get diffused, then definitely electricity will not flow. That is the part of discussion. Now, which bulb will give more light, that we are going to discuss. More the current, more the light. Suppose the first resistor is of 2 ohm, second is of 3 ohm, and this potential difference, that cell what we have connected, that is 18 volt. That means potential difference in between or across these two resistors is 18 volt. Suppose we have connected only one resistor R1, then what should be the current? If only R1 is in circuit, that is R1 is of 2 ohm. Now here R is equal to V divided by I. That is the formula we have learnt. Then here, because of interchange, I is equal to V divided by R. That change in formula we are going to get. So what is potential difference applied here? It is 18 volt. And only one. See, both bulbs have not connected in series. Only one bulb. That point we are discussing. And now 2 ohm, only one bulb is in the circuit, then resistance of the circuit is 2, then definitely we are getting 9 ampere current within this one, when only R1 resistor, one bulb is in the circuit. Suppose now only R2 bulb is in the circuit. So what is here? If only R2 is in circuit, so definitely here R is equal to V divided by I. So I is equal to V upon R. So value of R is 18 and value of V is 18 and R is 3. So here we are getting here 6 ampere. So what is current in case of R1? If R1 is in the circuit, then current is 9 ampere. And when R2, only R2 is in circuit, then current is 6 ampere. So if you compare both this one, which bulb will give more light? Definitely here, as resistance is more, definitely the heat energy creation is also more. But here within this one, current in this combination is more. Why? Because we are having the less resistance. Now both resistors are in series. That means RS, effective resistance in series, is equal to, last session we have discussed the formula. Resistance in series is equal to sum of resistances of individual resistance or resistors. So R1 plus R2. R1 is of 2 ohm and R2 is of 3 ohm. So totally we having here 5 ohm resistance. So now RS is equal to V divided by R. Why RS? Resistance in series, the effective resistance in series combination. So here I is equal to V upon RS. So value of V is 18 and RS is 5. So what should be the answer? Here 3.66 ampere. Again current get decreased or not? Because of increased resistance, current has decreased. So within this combination, if you are increasing the resistance by arranging it in series combination, definitely resistance get increased, and because of increased resistance, current decreases, and definitely this combination will not give more light or bright light than the previous. If you connect R1, if you connect R2 only and the second combination is series, definitely because of increased resistance, light giving capacity of the circuit get decreased. Two more points again we are going to discuss, and that points are, see here, a superconductor and non-ohmic conductor. What is meant by superconductor? Conductor are those who having least resistivity or least resistance. And what is meant by insulator? Those who having infinite resistivity, that means electrons will not flow. So what is superconductor? See here, the resistance of some conductor becomes nearly zero, not zero. Whatever may be the resistor, they should have the resistor or they having resistance. So not in the world we do not having such a material which are having the zero resistance. Whatever be the negligible resistance, and so we are taking this term nearly zero, not zero, nearly zero. Then the resistance of some conductors becomes nearly zero when if their temperature is decreased up to a certain value which is close to 0 Kelvin. It is not okay, it is 0 Kelvin. So when value close to 0 Kelvin, such conductors are called as superconductors. We having some examples. Which are they? Aluminium is a superconductor. Then niobium and magnesium boride. These are the some examples of superconductor. Then we have discussed Ohm's law. What is Ohm's law? Current in the circuit is directly proportional to potential difference used across the two ends when four things are constant. Which are they? Length of wire, area of cross section, material, and the temperature that we have discussed in earlier sessions. So the conductors which follow this rule, that means current in the circuit is directly proportional to potential difference. If you increase the potential difference, current get increased. So this law is not applicable to this conductor, so it is non-ohmic. Non-ohmic, those conductors are not following the law of Ohm, and so such conductors are called as non-ohmic. So what is the definition of this? Some conductors do not obey Ohm's law. Such conductors are called as non-ohmic conductors. So conductors are classified into two parts: ohmic conductors and non-ohmic conductors. You will get more information about the superconductor, ohmic conductor, and non-ohmic conductors in the higher standards. Second combination is a resistance or resistor in parallel. See, this question we are going to deal or discuss as a comparative study in between series and the parallel. See what is here? What we have discussed there? When resistors are connected to end, one after another, forming a single line, that is called as series. But what is the first here? When ends of resistors are connected at both sides. See here. One end resistor, this is R1, this one is a R2, and this one is a R3. So one end is connected at one side only, and second end also connected at the same point. So here, when ends of resistors are connected at both sides, the resistors are there. The resistors are said to be connected in parallel, not one after another. देखो ये क्या हुआ है, रेसिस्टर्स का वन एंड एक ही जगह पर यहाँ कनेक्ट किया गया है और दूसरा एंड भी वहीं पे एक ही जगह पे कनेक्ट किया गया है. Such kind of combination is called as the parallel connection. See here, second, what we have discussed while discussing the series, wherever you go, current in each resistor is same, but here current is not same. See here, suppose you are going to start the current, electron close the circuit, electrons starts to flow from one end to another end. That means here, as electrons are flowing, and when electrons reach this point, now three routes are there. Suppose you want to reach the Kolhapur from Jaisimpur. Different kind of ways are there. Which way will you adopt? The way on which traffic is less. That means less the traffic, more the current. Like this here, less the resistance, more the current. Suppose this is of 2 ohm, this is of 3 ohm, and this is of 5 ohm. Then R1 is less than R2 and R2 is less than R3. So here we having resistance more, so definitely electrons will not flow with great speed within this third resistor. Why? Because resistance increases, current decreases. So out of these three, which resistor having less resistance? Number 1, that is R1, that is only 2 ohm. So as resistance is less, definitely through this first way or first wire, current is more. Then current decreases to R2, because here R2's resistance is more than R1. So as resistance increases, definitely current decreases. And which is the highest resistance? That is R3, that is 5 ohm, for example. So definitely current in the first wire, current in the second wire, and current in the third wire get changed because of change in resistance of resistors. And so we have to connect separate ammeters for each and every wire. So if R1 is there, within this wire we are getting I1, that means current number 1. Here we are getting I2, and in the third wire, whatever may be current, that current or flow of electron is considered as a I3. So R1 having I1 current, R2 having I2 current, then resistor number 3 having I3 current. So in the series, current is same across each conductor or each resistor, but here current is different with the different resistors. But here, see, whatever may be the electrons reached here, the same electrons will flow or will come out of this. यहाँ कहाँ से भी रेसिस्टेंस जाएंगे तो वापस कहाँ आएंगे, यहाँ आएंगे. So potential difference is not get changed, because whatever may be the doors, suppose one wall is there, and for that wall 3 entrance gate is there or are there, and people are approaching towards that hall through these 3 different doors. So definitely whatever may be the people get entered, you will get in the hall or not. That means how many reach near the gate and how many reach inside the hall, that difference definitely same, because it is only one circuit. So like this one here, potential difference in between these 3 conductor or resistor is same. So here potential difference V is constant. In series, current is constant, potential difference get different or get changed. But here in parallel, current get changed but potential difference remains same across the 3 conductors or resistors. And so the first point we are learning here, potential difference is constant in parallel connection. Second, see, this potential difference is constant, what varies? There is a variation in current, but whatever may be the electrons by the first route, by the second route, by the third route, again they will reach here and together they will flow or not. So total current in this main circuit is equal to current from the first wire, current from the second wire, current from the third wire. Suppose you having 3 uncle. Then first uncle brought 5 chocolates. Second uncle brought or gave you 10 chocolates, and the last third uncle gave you some more chocolates. So whatever may be the mean or way of adopting the chocolate, total chocolate is equal to chocolate given by the first plus second plus third or not. So like this one, total current in the circuit is equal to current in the first resistor, that is I1, plus current in the second resistor, that is I2, plus current in the third resistor, that is I3. So what we got here, total current is equal to the sum of currents flowing through individual resistors. That means I is equal to I1 plus I2 plus I3. But we having one formula. Which one? Current is equal to V divided by R. Which formula we having? We having here R is equal to V upon I. This formula we having or not? With the help of this formula, we have derived this formula. So I is equal to V upon R. So here R is not ordinary R here. Here we have connected that one in parallel. So we have taken RP. So when I is equal to V upon RP, so definitely I1 is equal to R get changed V upon R1, then I2 is equal to V upon R2, and I3 is equal to V upon R3. So see here, I is equal to I1 plus I2 plus I3. Total current is equal to current in the first resistor plus current in the second resistor plus current in the third resistor. So can we fill this value within these equations? So we are getting here V upon Rp is equal to V upon R1 plus V upon R2 plus V upon R3. So as V is common, 1 upon Rp is equal to V into bracket 1 upon R1 plus 1 upon R2 plus 1 upon R3. That final equation we are getting. So as they are saying, get cancelled. So finally we are reaching Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So what is here? Rp effective resistance in series, but 1 upon Rp is considered as or known as inverse of effective resistance. So it is inverse of R1, it is inverse of R2, it is inverse of R3. So this is sum of inverses of individual resistance. Getting or not? It is the inverse of resistance and sum. So how it should be read? See here, 1 upon Rp. Inverse of effective resistance is in parallel is equal to, once again, inverse of effective resistance in parallel combination is equal to sum of inverses of individual resistors or resistance of a resistor. Suppose only 3 resistors are there, so only this equation will get stopped here. But suppose many resistors you have combined, so you have to change this like this. 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus so on plus 1 upon Rn for the nth number of resistors. So how many points we got here? Just we have got 3 points. As a combination or as a comparison, in series current is constant across the resistor. In parallel combination, potential difference is constant across each resistor. Then here main total potential difference is equal to sum of individual potential differences of individual resistor. Here total current is equal to sum of currents flowing through individual resistor. Then here there we have what Rs is equal to R1 plus R2 plus R3. Here we are getting 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. That means inverse of effective resistance is equal to sum of inverses of individual resistance of the resistors. See here, the inverse of effective resistance is equal to sum of the inverses of individual resistances. Then the next point, an important point, see here. The effective resistance is less than the least resistance of an individual resistor. In series we have discussed it is the more than the most resistor. Here, see how. Suppose R1 is of 2 ohm and R2 is of 3 ohm and these are connected in parallel combination. So 1 upon Rp is equal to 1 upon R1 plus 1 upon R2, that is equal to 1 upon 2 plus 1 upon 3. Denominators are not same, so we have to make the denominator same by multiplying numerator denominator by 3 and here by 2. So here 1 upon 2 into 3 into 3 plus 1 upon 3 into 2 into 2. So we are getting here 3 upon 6 plus 2 upon 6. So finally we are reaching here 3 plus 2 divided by 6. So it is the value of 1 upon Rp. So some part I am conducting here. So as 1 upon Rp is equal to 5 upon 6. So in our table Rp upon 1 is equal to 6 upon 5. And the final answer we are getting 5 ones are 5, then 5 ones are 10. That is 1.2 ohm. So see here 1.2 is less. Out of 3 and 2, which one is the least? 2 is the least or not? कम से कम होता है. That means 1.2 is less than this least. And see here, as you are having the bigger resistors of more resistance and you want to decrease the resistance, then definitely this combination is useful. So this arrangement is used to reduce the resistance. Then in our home, what appliances we are using, all are in parallel combination or connected in parallel, and so resistance get decreased and so we are getting the more current. Examples and remaining thing we will discuss in the next session. Thank you.